Yeah, so yeah, in this one we're looking at 3 tan squared x minus 4 equals -3, and we're kind of starting off, so we're mainly just looking at isolating the trig function as our general strategy. We're not doing anything crazy yet. So this is our warm-up. But we also gives us a chance to talk about the various answers. For example, we may look at over an interval. We may look at all reals. It kind of depends on what the problem's asking for. So for practice sake, I'm going to cover everybody. Just got to read every question to see which one they're asking for that particular problem. Now the good news, this guy's not too bad. Good old-fashioned algebra skills kick in. And if it helps, you can replace the tangent of x with a variable and just go ahead and solve that if that works better for the way you think.
Whoa, wait.
Which it
made it brighter for a second.
Oh, okay.
Back.
So
whatever you just did.
I just popped open the window. I don't think that did it. So you could write this as 3u squared minus 4 equals -3 and solve. So if that's something that flows better with your style of writing, you can do that. For practice, I'm generally going to continue writing it with the tangent, just so we don't lose it. For the harder problems, u substitution's a good plan. So 3 tangent squared, oops, not 3t squared, 3 tangent squared x minus 4 equals -3. So I'm going to add 4 to both sides. So that gives me 3 tangent squared x equals 1. Divide off that 3. I get tangent squared x is 1/3. And that means tangent of x is the square root of that. Now I'm not technically allowed to have...
Wait.
What?
I thought it was 3 equals side though. Copy it.
Hmm? Okay. What's that? I can kill one bank. Pick a side. Let's see if that helps. Better?
Yeah.
Okay.
Are you still recording?
And well, I'm lit, so it's all good. Better way to write that would be square root of 3 divided by 3, because that's what we're looking at. Now, what I'm going to do with this, if that's the case where tangent of x equals that means that x is the inverse tangent of root 3/3. And here's where the various answers come into play. I know from the unit circle, if I look for the angle where I have an xy that's going to give me root 3/3, I'm looking at 30 degrees. And for our purposes, I'm going to write that as the radian answer of pi/6. But that's not the only place it happens, is it?
No.
Where else do I encounter a tangent which is positive? When it's negative, so what quadrant do I have to go to? Down here into the third quadrant, I'm also going to have an answer that has that same result. And so that's going to be pi plus a sixth, or 7 pi/6. So if I write that as an answer, I'm providing an answer that's within the interval of 0 to 2 pi. Actually, we usually write it as, the other flip those around, parentheses and bracket. That works. If I just want an answer that's confined to the usual inverses, tangents usually confined to quadrants 1 and 4, and so that would mean my answer is just pi/6. And that's if my answer has to be between -pi/2 and pi/2. Colleen?
Really dumb question.
No such thing.
No, there's really is. Which one's the open circle and closed one again?
Curved is open.
Okay.
Solid is closed. And the way you remember that, remember how you can never reach infinity? You can never actually get that high? And infinity's got curves on it, so we always curve it.
Okay.
So that's kind of the mnemonic I've always used to keep it straight. What's up?
Why'd you eliminate 7 pi over 6?
Because 7 pi over 6 doesn't fit within the traditional interval for inverses.
Is that what we're supposed
It's
to
a
use?
bracket,
Right.
Wait, why doesn't it?
Because
Oh, because it's top and bottom.
right, remember when we first talked about inverses, we wanted to limit our answers to have only one, so we'd have an inverse function. So I had to limit my answers for tangent to be in quadrants 1 and quadrant 4. So I had to put those restraints on there. So if my answer is limited to just the unit circle, I have 2 answers. If it's just limited to the traditional inverse functions, I have 1 answer at pi sixths. And here's the last possibility, which is pi sixths plus 2k pi and 7 pi sixths plus 2k pi. And in this case, my answer is all real numbers.
What is Z?
Z is one way that they write all reals.
I thought you used an R.
I think that's used for rationals.
I thought it was R with an extra line.
Yeah.
Keep life simple. We'll just do that then. And I'll look it up in a second to be sure I'm being consistent. But the real big idea is it's all reals down here.
Why did you put 7 pi 6?
Because if we're talking all reals, every time I loop around that unit circle, I'm hitting another answer.
But wouldn't pi 6 cover that too?
You could write it as pi sixths plus k pi.
Oh, okay.
That would do the same job.
And then that way I wouldn't have to add the other one.
Bingo.